Hi everyone. Super happy to see you all here. That's my third Breakpoint, and I'm always happy to come and see all the builders, all the security people, if there are any here. I think I'm gonna need the clicker. Cheers, thank you. What I would like to talk to you today is, share a bit of research on what types of bugs you can expect in your projects. Because, kind of like in the title, back in the future, we see, like time and time again, there are similarities across projects. There are similarities across, implementation, or at least components of the implementation, and so the bugs that we see, they do seem to, occur in projects, regardless even of the industry and the and where the product fits in the market. So that's what I'd like to talk to you about in like the next 15 or so minutes. And so I'm head up enterprise security at Halborn. I also do Solana hands-on, security engineer, dev advisor to project. Started blockchain 2019, and I've been working on Solana since 2021. There are a couple of steps that we need to take to fully try and understand what we can expect in the future, because there's this one concept in mathematics called Bayesian probability, and it's basically around how we can project and forecast probabilities based on the data that we already have. And so the number one step in our little exercise is to get the data. And so well, the fact is that whatever scoring system your security services provider is using, there's a pretty good chance that it's not actually working too well, and there's a very good reason for that. And so, if you look at any of these matrices here, they have one thing in common: they're two-dimensional, and you have you have scales on each axis. Why is this? And it's super simple, and it tells you quite a lot. And if something is red, if something is 25, if the scales are from 1 to 5, that means usually it's pretty bad. Just the y-axis here is likelihood, and then we have consequence, which can be thought as impact. And you might want to ask yourself, what is likelihood? Well, likelihood is just probability. And so what's impact? What's a consequence? How do you measure that? Like, what's this consequence 5 is 2.5 times as bad as consequence 2? How does it scale? And so back to the high school theory of probability. We have apples, on one axis and oranges on the other, and the reason for that is you can't really mix two universes of discourse. If you have probability, you can only work on probabilities. If you have any other unit or any other universe of discourse, you can't really mix them up with probability, because if you multiply something by probability, you end up with a scaled probability and not some hybrid type of monster unit. So there are no mathematical laws that would govern these types of operation, but seems like no one really cares as long as it's visible and easy to understand. Because convenience matters more. It's easier to convey the message to people that are not so fixed on mathematics and scientific correctness of the metrics. while it may not be mathematically correct, there surely is some middle ground between convenience and correctness. And seems like there are some people that have it figured out, and there are some who are still yet to do that. And so when we compare how we collect data about vulnerabilities in a Web 2 world, that's the multi-dimensional plane that I have on the right side of the slide, whereas all we know about vulnerabilities in Web 3 is this little two-dimensional scale. Now, if you compare the wealth of information that you can extract from the multi-dimensional plane versus two-dimensional plane, now there's only so much you can see in a flat land. And so what the next step should be is to try and redesign the system just so it's usable and you can project from that to the future. Because back to one of the earlier slides with the matrix. Now, when you see score 25, the issue is bad, but you don't know anything else about it. That's as much as as much detail as you're going to get from it. Whether it's deposit affected, yield, availability, integrity of your data, you have virtually no idea just by looking at this metric, even if it says catastrophic or something. So basically, what we tried to do at Halborn is bring order to the data set. And there is a pretty robust and well-recognized system called CVSS, that stands for Common Vulnerability Scoring System, which is really popular and really commonly used in Web 2 security. But the thing about CVSS is it lacks some metrics that capture things that are quite important to us, in the Web 3 world. And so in its current form, it might not be the perfect tool, it might not be the perfect system to use that, to apply to blockchain, to smart contracts, to programs. And so we sort of took the best of both worlds and came up with a blockchain vulnerability scoring system by leveraging the design of CVSS, but enriching it with blockchain-specific metrics. And so here's like a super short breakdown of what the metrics are. So back to the two-dimensional metrics, we have likelihood and we have impact. Now, because that does not really tell us much, we decided to break it into more descriptive categories. And so for exploitability, which is basically telling us how difficult, how complex it is to exploit a vulnerability, we have attack origin as to who's the actor that can exploit or trigger the vulnerability or the bug. We have the cost, as in, well, is it economically beneficial to the attacker to even try and exploit this vulnerability? And we have complexity, vis-a-vis how difficult it is for the attacker to exploit the vulnerability in the sense of external factors that are outside of his or her control. Now, for impact, we decided to also go into a bit more detail, and so we have the CIA triad, which stands for confidentiality, integrity, and availability, and so 3 basic attributes of information security. And as to more blockchain-specific metrics, we have deposit, as in how are the funds that were deposited in the contract are affected. And so your user deposits, your treasury, and what have you. And the 5th parameter is yield. And so how rewards are affected, if you do yield farming, anything that's not supplied by the depositors. Another metric is reversibility, as to whether, whether this attack the consequences of the attack can be reversed or not, and scope, whether the issue is isolated to one project only or whether it is perhaps systemic. And once we have our data set, once we organized our data set, we can proceed to analyzing the data, and that's what I'd like to focus on for the next couple of minutes. And so if we look at the vulnerabilities that we've identified, it looks like every one of 5 vulnerabilities has, impact on deposit, whether it's, insignificant, as in very small, or whether, it's a bit worse. And if there is impact on deposit, how bad it is. So we can see that most of the time, if there is impact on deposit, it's actually, rather bad. So it's not like you're going to lose, 10% of your treasury. It's more like 80%. And similarly, yield. Yield seems to be, a bit more protected than deposit, surprisingly. And so, about 80% projects are unaffected. However, if the impact is non-zero on yield, like 40% of the time, it's devastating to your treasury, to your project. And so, seems like yield is affected, rarely, but if it is, it's really bad. So considering impact on deposit and yield, so both the rewards, both the deposits are affected, only 9% of all vulnerabilities are that bad. And if we look at like an extinction level event for a project, fortunately that's just 1% of all the cases. But it's still 1% that shouldn't even be there, because within those 99%, we have this chart, we have the previous charts that I showed you, so there's a lot. Just looking at what's most affected by vulnerabilities, definitely integrity, and so you can think about it as data like the write operation that's affected the most. Then we have deposit. Sorry, I might be confused a little about colors, so take it with a grain of salt. But confidentiality, because it's not that much of an issue for a project if it's not leveraging ZK or privacy capabilities. It doesn't happen too often. Now, difficulty, we can see at the equation in the top. Complexity means the external factors for an attacker are not too, putting it another way, the attack, there must be something happening that the attacker does not have control of to be able to pull off the attack. And so cost is medium and lower than medium, and so it's reasonably cheap to exploit. And so most of the attacks are rather simple to exploit. Environmental impact, that is a metric that shows us whether the issue is systemic or local. So most of the time the issue is isolated to this one project. And similarly to attack origin, most of the time the bug can be triggered by anyone, any public key, any address, and in 30% of cases it's some sort of a centralization issue, either ownership or role management, or more generally role-based access control. So as to reversibility, unfortunately most of the attacks are irreversible and there's nothing you can do to recover the funds. And the severity chart, definitely most of the issues are informational, and so that's a improvement suggestion rather than a security concern. And the most critical vulnerabilities, they are, up about 10% of all the vulnerabilities that we identify. It's still, 1 in 10. It's a lot still. So like ideally, as the ecosystem grows, we'd rather see the blue field, becoming more and more, present in the chart. So now that we know what types of vulnerabilities we can, expect, most of these are business logic related. Like every single auditor that I've talked to, like the very first advice that they give is, never to forget the common Solana vulnerabilities, the ones that, we at Halborn and, other companies, we've been trying to, educate the ecosystem on, how not to make the same mistake. And so let's just review them real quick with a, bug and fix way. And so the first one, account owner check missing. We all know that every program can read any account in Solana, but there are cases where you'd rather know who created this account, and so it's better to check the owner matches the expected owner matches the owner key. It seems like the description is not actually right, but that's the gist here. The owner must match your expectations. And so, again, signer check missing. Like we don't have this capability in Solana. We have to validate the signers manually. And to this end, we can use the isSigner field. Now, there's obviously a disclaimer that all this applies to native programs and a specific subset of Anchor programs too. And so the isSigner field in account info struct, you can use it to verify if the sender of the transaction is one of the signers of the transaction, because that's not going to be always the case. And if you need to confirm the identity of the sender, that's what you need to check. Now, if you integrate with other programs, like for example, you want to make a transfer and you require the, either the delegate or the owner of the token account to send the funds. Now, SPL token will happily do this sort of validation for you. But if you do not, you're definitely better off checking it yourself. Plus, it's not too expensive in Solana, so why not do that? So arbitrary program invocation. So CPIs, cross-program invocation. So they're basically, in a cybersecurity world, you could even call it remote code execution, which means that you delegate, the identity per se of and the context to a separate program, separate piece of software that executes this code. And so if we, obviously we have to provide all the account infos, and so the destination of the instruction is going to be included in the account info slice. If you don't validate the destination, again, you might want to, an attacker can redirect the flow of the application to a program of their choosing. And, it can be as simple as, bypassing validation, or, it can be something a bit more sophisticated as, as was in the case of the wormhole hack by, reconstructing the entire signature that the program was expecting. And a bit related to arbitrary program invocation, we have PDA signature hijacking. It's similar in the sense that it also leverages cross-program invocations, but it also propagates the signature of the program. And so someone, if you don't validate the destination of the instruction, someone could hijack the signature of the program. And two other bugs that I wanted to talk today are from Anchor. Sorry, we've got account type confusion left. So with account type confusion, in Solana, serialization format is context unaware. And so just to put it quickly, once you have to know what you're serializing and deserializing the data to. If you do not, those random bytes are just going to be interpreted according to the schema the deserializer is going to expect, unless you verify it by, for example, account identifiers that Anchor provides you out of the box. And talking about Anchor, two of my favorite types of vulnerabilities, so remaining accounts and account infos in contexts with, you have to remember that these remaining accounts or anything that's account info is not validated. No Anchor security checks are going to be applied, and if there are none, you have to check all these common vulnerabilities yourself, because you can introduce some very nasty bugs to your code if you're not doing that. So thank you so much for being here. Appreciate the attention. Enjoy the rest of the Breakpoint. Thanks, guys.